Bismillah ar-Rahman ar-Rahim, my dear students. This is our first topic in pharmaceutical dosage forms 1. It's about the dosage form powders and the other dosage form granules. So we are talking here about two different dosage forms. In every topic we are going to start with the objectives or the outcomes of the topic. So as a student studying this topic, what you are supposed to be able to answer by the end of this topic when we complete the topic. So our first outcome is how to differentiate between powder form and granule form. Now these are two different forms, so how can you differentiate between them? The other outcome is to explain the effect and the influence of particle size. Particle size can influence not only the pharmaceutical dosage form, but it can influence other properties that the powder has. And we will talk about that in more details. Also, you are supposed to define micromeritics. What do we mean by micromeritics? طبعا micro, you know what is micro, it's a small thing. And micromeritics actually is defined as the science of small particles. So any property relating to the small particles such as size, flow, shape, etc. is studied under micromeritics. Also, you are supposed to know what is ligation and what is the process of spatulation and trituration. Also, as outcome, you are supposed to be able to differentiate between various types of medicated powders. Yani the dosage form, which is powders, can be classified in different ways. One of these classification is bulk powder and divided powder. So what is the difference between both presentations? Also, we need from you to tell us some examples of medicated powders, whether that in the form of prescription or non-prescription products. I assume that you know what do we mean by prescription and non-prescription. When we say prescription, it means the medication is dispensed under an order that is prescription from a physician, and non-prescription indicates that the patient can as well pick the product for him or herself. Also, as an outcome, you are supposed to differentiate between fusion method, and this is a method of preparation, and another method of preparation is wet method, in the preparation of effervescent salts. And here we are talking about the preparation that cause reaction when you put this preparation or the granules in a glass of water. It will cause a reaction, and this reaction releases bubbles, releases CO2, and this causes the effervescence, يعني الفوار, المستحضرات الفوارة. And the reaction causes what we call fizziness. يعني what you hear when you put the salt in water or put the granules in water, you hear a salt, you hear a voice, and that is the fizziness of the reaction. Whenever we start with a dosage form, we will start by defining the dosage form. And when you want to define a dosage form such as powders or granules or tablets, usually you start with describing the shape, and then usually how it is made and what it is intended for. So let us talk about powders. Now, how does it look like? Is it liquid? What is it? Now, first, and this will allow you to imagine what we are talking about, first we define it as solid. So now it's not liquid, it's a solid, dry pharmaceutical preparation, so it's in the dry form, it's not wet, okay, and it's composed of finely divided particles. Now I can imagine how it looks like. So I'm talking about things like what you have in the house, for example, the salt, the table salt. It's a powder. It's composed of finely divided particles. But of course, the salt in the house is not, the table salt is not actually a medicine, but you can actually, from this definition, you can imagine this dosage form. So now we described how it looks like. Now we will describe the purpose. The purpose of this medicated powders is for internal use or external use. Internal use يعني oral powder, يعني in the end you will take it orally. External use يعني you will apply it topically على, of course, mainly the skin. Okay, from the definition of granules you will start to pick up ايش الدifference between powders and granules. Now granules on the other hand, they are made from powders. يعني the source of granules اللي هو the beginning is powdered materials. Now these powdered materials, they are prepared as agglomerates. That's why we call or we define granules as prepared agglomerates of powdered materials. Now, what do we mean by agglomerates? We are talking here about gathering of fine particles together to form larger entities. We call them granules. So the gathering, how do you gather the particles together? You need to stick them together by certain forces to allow them to become like agglomerates. طيب, let's complete the definition. So now we know the shape. It's sticking of particles. Maybe someone will ask me how many particles. Well, it depends. It can be, for example, few particles, maybe to hundreds of particles. So it depends actually on the process of preparation. So these aggregates, the agglomerates of powdered materials, what do we use them for? We can use them as they are. So our dosage form is granules, or in most cases we are using them as intermediate step. Yani they are not the final dosage form. They are used for making other dosage forms, for example, in making tablets. Now, most tablets that are in the market, they are made after making the granules. So we make the granules, then we can make the tablets. طبعا someone might ask, okay, why do we need to prepare granules in order to prepare tablets? We can discuss that later. But we can make tablets and we can also fill the granules, for example, in capsules. طيب, so what is the definition of granules? These are prepared agglomerates of powdered materials that may be used as such for their medicinal value of their content. يعني we can use them as granules كدosage form, or we can use them for other pharmaceutical purposes, يعني intermediate step, يعني مش final step إنه the dosage form is granules. We can use them to make tablets, or as I told you, fill them in the capsule shells. Now, if we want to look at the difference, so how the shape would look like, if I say, okay, these are powders. You see here finely divided powders. Okay, and here you can see agglomerates of powdered material to form entities. We call them granules. طبعا maybe you will conclude that, okay, the granules should be larger than the powders. Well, that is a correct conclusion, but we have to be careful because we cannot, for example, divide the granules and the powders, divide them according to size. So we cannot say, for example, okay, so if it is actually the size is, let's say, less than 500 micrometer or less than 1000 micrometer, then I will call it powders. And if it is more than 1000 micrometer, then I will call it granules. This is not correct assumption, although generally we consider the granules are larger than powders. Okay, after talking about the definitions, now we want to talk about, we will focus on powders, and we will talk about the advantages of powders as dosage form. The first advantage is that powders are easier to swallow. Now, when I say it's easy to swallow or easier to swallow, I have to think always about comparison. So I'm comparing here powders with what? In this comparison, I'm comparing, for example, powders with, let's say, tablets or capsules as dosage form. Now, powders, usually, they are not swallowed as they are. Instead, they are suspended or dissolved in liquid, and then you can drink this liquid, or the patient can drink the liquid. In this case, of course, the swallowing will be easier, and this is a reason why pediatric population are usually prescribed liquid preparation, because it's easier to swallow liquid preparations compared to solid tablets or capsules. طيب, another thing is that you can have larger dose than tablets and capsules. So how does this how do you understand this? Of course, as I already said, that you can dissolve or suspend the powders in liquid, and then you can drink one cup or one glass of water that contains a lot of powder. So actually the amount of powder can be large compared, for example, to tablets and capsules. We cannot make the tablets like a big piece, because in this case you cannot swallow the tablet. You will eat the tablet like cake. So that's why tablets and capsules, they will have limited size, especially when we are talking about swallowing them. You cannot swallow a big piece of tablet or capsules. They have to be within certain size limits. Otherwise, no one will be able to swallow these tablets or capsules. So actually you can have larger amount of powders. طيب, another thing which is also important in terms of action. When I say action, means giving the effect. Which is faster? Is it the powders or the tablets? طبعا powders will have faster action usually than tablets. The reason is, who knows what is the reason? The reason for this is that powders, they are finely divided particles, already divided, and this will allow them to dissolve faster in the gastric juice. في stomach, they will dissolve faster. If they dissolve faster, they will be absorbed faster to the systemic circulation, to the blood. They will enter the blood faster than the drug from the tablets, because tablets will take more time to dissolve and therefore longer time to get absorbed. So powders will have faster-ish effect. طيب, another advantage is that powders are more stable than liquid. To present the powder as solid is more stable than putting this powder or dissolving it or suspending it in a liquid. The reason is what? Do you know what is the reason? Now, the presence of particles in the liquid will allow the degradation reactions for example, especially hydrolysis if it is water, and even oxidation and other reactions to proceed faster. That's why some dosage forms are available as powders, such as some penicillin's derivatives, for example amoxicillin. If you want liquid amoxicillin, you will not find liquid amoxicillin. Instead, they will give you a bottle that has the amoxicillin as a powder, and then they will ask you to pour water to a certain level inside the bottle and shake the bottle well for you to take the antibiotic, amoxicillin antibiotic. So you have to do this step at home maybe, or maybe the pharmacist will do it for you. But in any case, why is this happening? Amoxicillin is known to undergo hydrolysis in water. So if the company wants to prepare for you amoxicillin as a liquid preparation, then it will expire very quickly. Instead, what they do is they prepare it as powders, and then they will ask you, okay, when you want to start taking this antibiotic, then you can add water to it, and then you have to discard it up to within 2 weeks. Of course, usually you will take the antibiotic maybe for 1 week or 5 days, and then you will discard the medication. طيب, what are the disadvantages of powders? The main disadvantage is that the taste is difficult to hide. If the drug has bad taste, then how can you hide this taste? Of course, you can add sugar, you can add other flavoring agents, but when you compare this, for example, to putting the drug inside capsules, inside the capsules it will be completely or the taste will be completely hidden inside the capsule shells, and the patient will not feel any of the drug taste at all. Yes, adding the flavoring agent and sweetening agent can reduce the problem, but still it's maybe not good enough as the case with capsules. Okay, so now we talked about definitions and we talked about advantages and disadvantages. Let us talk about particle size and analysis. If you remember in the outcomes, we said it's very important to know about the effect of particle size. Now, particle size plays a major role in many different processes. I will talk about these later and I will explain it to you. But let us begin by talking about the classification of powders, okay, the classification of powders according to United States Pharmacopoeia, and using what? This classification is based on what size analysis? طبعا it's according to size. You are analyzing the powders according to size. But my question is, what is the method of size analysis? Okay, what is the method of size analysis that you will use in order to classify powders according to size? Now, in the United States Pharmacopoeia, they classify powders according to size to very coarse, يعني خشن كتير, very coarse, coarse, moderately coarse, fine, and very fine. So here we are talking about 5 classifications of powders. Now, what is the method of analysis they used to classify the powder? Did they use microscope, for example, to look at the size and classify the powders to 5 classes? Did they use any other method? No. These classifications are only based on sieve analysis. Sieve analysis. sieve يعني المنخل. Okay? اللي هو عبارة عن mesh. There is a mesh and you look at the size of powders according to how they pass through the mesh. I will talk about this later on. But originally, the United States Pharmacopoeia, they said, what did they say, the pharmacopoeial people? They said, well, these powders that we classify them to very coarse, coarse, moderately coarse, fine, very fine, these powders are from vegetable or animal origin. Now someone might ask, what if it is from other origin, like chemical origin, synthetic يعني? Well, we can still use these terms, very coarse, coarse, we can still use them, but mainly they are useful to classify powders coming from vegetable and animal sources. طيب, إذن let's say the following. There are 5 classification of powders according to sizing by sieves. Okay? And this is according to United States Pharmacopoeia. So here there is a question, according to what? Here the answer is according to sieve analysis. So the size analysis method that we use is sieve analysis. So what is sieve? This is the sieve. You see, this is the wall of the mesh, hadal mesh, and it's housed inside a wall. And this mesh contains apertures. Usually they are square apertures, يعني مربعات. And the wires can be made from brass, stainless steel, copper. So there are many different materials that we can have in the mesh. Now someone might ask, okay, which one is better? Well, it depends on the material we use, but usually the stainless steel one is very good for or resistant to many interaction with different drugs. طيب, okay, what do you see here? So we started now talking about sieves and the openings. The opening in the sieves here are all of the same size. يعني السكويرز اللي موجودة, the squares that are in this figure that you see here are all of the same size. Now if you look at the table 6.1, the opening of the sieves, or let's say sieve number and sieve opening size. طلع على 2 columns, sieve number, sieve opening size. So when we say sieve number 2, معناته this means the aperture size is 9.5 millimeter each opening. When we say sieve number 3.5, this means the opening, each square opening size is 5.6. When we say 4, it's 4.75. When we say 8, it's 2.36. So when we say, let's say 100, it's 150 micrometer. يعني الفتحات هون, okay, the openings here are 150 micrometer. When we say 400, معناته the size of the aperture is 38 micrometer. You will notice that the larger the number, كل ما زاد الرقم, okay, the smaller is the opening size of the mesh. يعني راح يكون عندنا sieve, we will have sieves with different openings, okay, to use them to classify powders. Okay, I will explain this more. Now, how do they call the sieve number, and what's the relationship between sieve number and sieve opening? You have noticed that when the sieve number increases, what happens to the size of the opening? You will see that the size of the opening decreases. Okay? طبعا here I am assuming that all of you know, شو بتعرفوا؟ إنه each 1 millimeter is equal to how many micrometers? Okay? Does anybody know how many micrometers? How many micrometers? Okay, each 1 millimeter is equal to 1000 micrometer. Okay? So as you see here, as the number sieve number increases the opening size بصير له ايش decreases بصير السايز اصغر. Okay, so what is the relation? I mean, how come the opening increases, okay, the sieve number, sorry, increases and the size of the aperture decreases? Well, what they do is when they say sieve number 2, it means in 1 inch of the sieve, in 1 inch of the sieve, okay, there are 2 openings. So if this is 1 inch in the sieve, there will be 2 openings. If there is, if I have sieve number 4, okay, sieve number 4, this means that in 1 inch you have 4 openings. So if you compare the number of openings here with the number of openings here, okay, what do you see? You see here two openings, and here you have 4 openings, and both of them are in 1 inch. So the more openings you have, like in this case, I have here 4 and I have here 2 openings. The more openings you have, the smaller is the square. طبعا I drew them as circle, but in the mesh they are actually squares. Okay, that's why when I say, for example, 8, what does that mean? It means in 1 inch there are 8 openings. When I say 100, what does it mean? In 1 inch في عندنا كم؟ في عندنا 100 openings. Surely this aperture size will be smaller than, for example, there are 80 openings in 1 inch. That's why, see, 100 openings, the size is 150. If it is less, the number are less than 1 inch, the size increases. It's 180. Okay, so what do you understand now? You understand that powders are classified according to sieve analysis. Okay, according to sieve analysis. To very coarse, moderately coarse, fine, and very fine. And then you learned about the sieves. Okay. Now in sieve analysis, I want to show you actually a video. In this video, it will show you how to do size analysis using sieves. Okay. Normally we will have a series of sieves, يعني مجموعة من السيفز stacked on top of each other, يعني بنحطه فوق بعض. Okay, so that the sieve with the largest opening, okay, will be at the top, and the smallest opening will be at the bottom. وطبعا below that you will have a collector, يعني راح يكون في عندكم collector, so that the powder that passes through the last sieve will be collected in the collector or reservoir. Okay, so I will show you a video showing you how sieve analysis is done. Okay.
Despite technology changing so rapidly, the test sieve remains a cost-effective and precise measuring instrument for dry, non-agglomerating particles. Test sieve analysis is widely used for quality control in many industries worldwide. In pan, stack the sieves on top of each other with the finest or smallest opening on the...
Now I want you to notice, okay, here, notice here, sieve number 100. Here, sieve number 200. So what did he do? The 100, sieve number 100, it means their openings are larger than sieve number 200. And at the bottom, you will see the collector. Okay? So anything that passes sieve number 200 will be collected by the final reservoir, اللي هو collector we call it. So sieve number 100 is having an opening that is larger than 200. Then you can put something larger here above the 100, and then larger and larger. At the end, your powders that you want to do size analysis with, this powder has to be loaded على التوب sieve, the one that has the largest opening, and then it will be put in a mechanical shaker usually to shake the sieves. ليش بيسووا shaking للsieves? Why do they shake the sieves? So that the powder can fall through the different sieves according to their size, حسب الsize. Okay, let's see more here.
Bottom of the stack and proceed in ascending order. Use a laboratory scale, accurate to 1/10 gram, to weigh an empty container, usually an extra receiving pan, and establish a tare weight. Weigh the entire sample and record the weight. W.S. Tyler offers sieving software for basic spreadsheet analysis. Additional test information includes company name, test number, and date. This may be saved and used as a permanent printed record. Empty the entire sample into the top sieve of the stack. Make sure that you do not overload any sieve, as this may cause blinding. Place the stack in...
طبعا blinding here means what? It means if you put a lot of powder, طبعا usually we put 50 to 100 grams في ال 20 centimeter diameter sieve. If we put more than that, it can cause blinding of the apertures or of the openings of the sieve. Blinding يعني ايش? The particles can block the openings, and this will not cause correct analysis. Now you will see that the man is putting the stack of sieves or the series of sieves in a mechanical shaker. Now this mechanical shaker will be operated for 5, 10 or 15 minutes, and this will allow the powders to separate inside the different sieves according to the size of the sieve apertures.
The sieve shaker with a cover on the top sieve and securely fasten the stack into the shaker. A sound enclosure cabinet can be used to reduce operating noise levels. Set desired time limit and start the shaker. Again, the time limit is generally an instruction included in the product specification. When the test is complete, remove the stack of sieves from the shaker. Empty the sample material retained on the top sieve into the empty container. While holding the sieve over the container, gently brush the underside and inside of the sieve to remove all remaining particles. Weigh the contents in the pan and record data. Repeat these weighing steps for each sieve and bottom pan, making sure to collect all particles. Verify the new total sample weight against the original mass sample weight. Generally, a difference of...
Okay, what you will see here is that he's putting the weights that is returned in each sieve. يعني he loaded 100 grams, okay, and to the top sieve, and then he started the shaker, mechanical shaker, and at the end he weighted the amount of powder retained in each sieve. Okay, now this is important in size analysis. We will see later how we do size analysis. Okay, and it will allow us to classify powders according to their size in sieve analysis.
Less than 1% is acceptable. Tyler's sieving software will total the recorded weights, calculate cumulative weight retained, and a cumulative percentage retained or passing for each test sieve. In the absence of a software program, the same data must be recorded and then calculated. The software will configure a particle size distribution curve for the records with the...
Okay. Now, we know how we operate with sieves. So when do we describe the powders as very coarse powders? Now, if you do sieve analysis and you find out that all the particles pass through sieve number 8. Sieve number 8, if you go to the table above here, sieve number 8 has an aperture size of 2.36 millimeter. طيب, when we say that all particle pass through the sieve number 8, it means the largest particle size should be 2.36 millimeter. Now, who can tell me how many micrometer is this? How many micrometer? Can you calculate? Okay, if 1 millimeter is equal to 1000 micrometer, then here we are talking about 2360 micrometer. So all the particles will pass through the sieve 2.36 millimeter, معناته the largest size is 2.36 millimeter, and not all of the powder that you have loaded, not more than 20% of that powder, يعني if you load 100 gram, not more than 20 gram pass through sieve number 60. طيب, شو هو sieve number 60? Let's see here. Sieve number 60 is 250 micrometer. معناته I can tell the following. Suppose you have sieve here. Okay, 1 second. You have sieve, okay, and there is another sieve, and you have collector here. So now you have 3 sieves. This is sieve number 8, which is 2.36 millimeter, and this is sieve number 60, which is 250 micrometer. Okay, and suppose you put here 100 grams, then the 100 grams, all of it must pass through the first sieve, all of it. Okay, and then the 100 grams that comes here, not more than 20 can go to the collector. Okay, not more than 20 grams. يعني if all of the powder is between 250 and 2.36 is fine. If 5 grams pass here, it's also fine. The maximum that can pass through the sieve here is قديش? 20%, يعني 20 gram. In this case, what do you describe the powder? You describe the powder as إيش? As very coarse powders. Okay, now let's see if you understand this, and we'll apply it to the second class of powders, which is coarse. For coarse powders, now all the particles, خلينا نسوي erasing هون. All the particles that you loaded here must pass through the sieve number ايش؟ 20. 20 معناها ايش؟ 850 micrometer. So the powder that you loaded, all of it will pass through this sieve. يعني the largest size is 850, and then be careful, not more than 40% pass through the sieve number 60. 60 اللي هو ايش؟ 250 micrometer. طيب, if you load 100 grams, so all of it will pass into this sieve اللي هو 250 micrometer, and from this sieve not more than 40%. معناته how many grams can pass maximum here into the collector? The maximum that can pass is قديش؟ 40 grams. This is the maximum. طيب, what about if it is less than 40 grams? It's fine. If it is 0, it's fine. Okay, as long as the maximum that can pass through the 250 micrometer is 40% or 40 gram in this case, in our example. So in this case, how do you describe the powder? What do you tell this powder? Is it very coarse? What is it? It's coarse. We say that this powder has can be described as coarse powders. طيب moderately coarse اللي هو number 40, all the particle will pass through ايش؟ through sieve number 40. طب السيف number 40 شو السايز الابرتشر تاعه؟ 425 micrometer, which means what is the largest size for powder? The largest size is 425 micrometer. And then not more than 40%, okay, pass through the sieve number 80. طب السيف number 80, what is the size for sieve number 80? It's 180 micrometer. شو معناته؟ What does that mean? That all the powder will have a maximum size of 425 micrometer, and not more than 40% of this powder is less than 180 micrometer. So you can apply the same thing in the figure. طيب يعني most of the powder will be between 180 and 425 micrometer. Okay, same thing for fine powders. Fine powders are those in which all the particle pass through sieve number 60 اللي هو 250 micrometer, and not more than 40% pass through sieve number 100 اللي هو ايش؟ 150 micrometer. معناته mainly the powder will be from 150 to 250. In this case we refer to powder as fine powders. Very fine powder اللي هو بيكون فيه all the particle pass through sieve number 80 اللي هو 180 micrometer. لا ما في limit للفاينس. يعني what I mean to say here is that we don't have the limits as in fine, moderately coarse or very coarse. خلاص all the particles are less than 180, يعني more than 0 and up to 180 micrometer. طيب what do you طبعا this classification, as I said, it's according to United States Pharmacopoeia. And what is the benefit from knowing or describing the powder as fine, very fine, etc.? The benefit is that the size can affect many processes in pharmacy. We will talk about few of them later on. Because I want you to understand that in general, طبعا there are many exceptions, but in general, granules are larger than powders, and typically they have a size from 2 to 4 millimeter. But also granules with smaller size like 0.85 millimeter to 2 millimeter are also used. يعني the larger granules are usually used when you are using granules as such كدosage form, but when you are using them as intermediate step in making tablets, usually the size is smaller. طبعا these ranges are not sharp ranges that cannot be something different. No, granules can be used alone as a dosage form with a size maybe less than this, 2 to 4. And in tablets it can be less than 0.85 to 2 millimeter. But here, just to make you imagine, or to allow you imagine how granules are usually larger than powders. طيب, so the question is, we are talking now about size, particle size of powders. What is the importance of particle size? It influences what? It affects what? Why in companies, in manufacturing companies, they need to control particle size? What is the reason for that? Well, think about it. First, the dissolution rate. Dissolution rate يعني how fast the drug will dissolve. طيب, the larger the particle, the faster is the dissolution rate, or the opposite of this? طيب, one thing you should know, that the smaller the particle, the larger is the specific surface area of the powder, and the faster it will dissolve. And the faster it dissolves, يعني when the powder dissolves faster, this will allow the action to be faster. Now I want you to consider the following. Suppose you have this particle, okay? Now what happens when you want to dissolve this particle? You put it in a liquid and start dissolving, or let's say this is in the GIT or in the gastric fluid, and start dissolving. The dissolution will happen from the surface. أي السيرفس يصير عندنا إيش؟ The molecules from the surface of the particle will start to إيش? To go into liquid and dissolve. This is what is happening. طيب. So the surface is important here because it's through the surface we are having the dissolution process. Now what happens if you break this particle to 3 parts? Suppose you have a knife or you have a cutter and you break them to this size, to this part, and this part. So now you have, what did you do? You increased the number of particles from 1 particle to 3 particles. This is number 1. So when you reduce the size, you increase the number of particles. Now what about the dissolution process? See, the dissolution process is also happening from the surface. طلع السيرفس برضو من السيرفس راح يصير عندنا dissolution, the same surface, but by breaking the size you have ايش؟ You have created new surfaces. يعني صار في surface داخلي هيو, because these particles will be ايش؟ Separated. So now you have surface in this side and surface in this side, surface in this side and surface in this side, surface in this side and surface in this side. So your surfaces have increased. The dissolution will not only be happening from the outer surface but also from the inner surfaces that you have created by ايش? You have created by breaking the particles to smaller parts. And this is one factor. That's why we like, or we must actually control the size of particles in order to control the dissolution rate and in order to control the effect of the medication. Another thing اللي هي suspendability of particles. يعني imagine that you have a suspension. Suspension شو يعني؟ تخيلوا you have a bottle containing suspended particles. Now what will happen to these particles? شو راح يصير لهدول البارتيكلز؟ What will happen to them? أكيد with time they will start settling down because of their weight and the gravity. Okay, they will start getting down. You have gravity and eventually they will settle down. That's why always when you dispense to patients a suspension preparation, you should ask the patient to shake well before use. طيب, what is the relation of size with the suspendability? Of course, the larger the size, كل ما كان السايز أكبر كل ما كان the faster the sedimentation. The sedimentation will be very fast. And this sedimentation is governed by a law. And I want you to go search in the books and find this law اللي هو Stokes law. Stokes law is, طبعا there is an equation. في هاي equation في عنا اللي هي the rate of sedimentation, سرعة sedimentation. The Stokes found out that the rate of sedimentation is proportional to the square of diameter of particles. يعني إذا diameter of the particle get little bit larger, the speed of sedimentation will be ايش affected significantly. So the rate of sedimentation is proportional to the ايش حكينا to the square of diameter of the particle. يعني it means that the effect of diameter is very strong. Okay, let me remove these things and talk about the third effect اللي هو uniformity of distribution in a powder mixture. طبعا rarely you will find a medication made of just only drug. Usually you need to mix a drug with a diluent or with excipients, يعني other materials. فإذا the drug is not alone. Because of that, it's very important to make sure that the drug is uniformly distributed in the powder mixture. شو يعني uniformly distributed? يعني if you take any part of the powder, you will find similar amount of drug. Not like in certain parts there is more drug than in other parts of the powder mixture. What is the effect of particle size on that? Okay, I want you to imagine the following. These are particles. Let's say large particles. Let's say this is powder A and this is powder B. This is powder B, and you want to mix them. Okay, you want to do a mixing. These are large particles, so you do the mixing and then you take a sample of, let's say, one particle. Now of course this particle will either contain A or it will contain B. صح؟ يعني your sample is actually ايش either containing A or B, which means this is a very bad mixture. So the solution for this is to break the particles to ايش very very small pieces. فبصير عندكم ايش you break all the particle to very small pieces, so now you have ايش particle in this way. Okay, and let me change the color, and this is the other type of particle. So now what I did is I broke the particles and then you mix them together. See, if I want to take quantity as much as this one after mixing, so I'm taking a quantity from here. After mixing, I expect to have, for example, something like this. Maybe the red color is less than the black color in the sample. Okay, so I have more black here. يعني component B maybe is more. Okay, this is not uniform, but at least what happened? You will not say that it's either A or B. There will be something from B or there will be something from A in the sample. So the bottom line here is that to improve uniformity of a mixture, it's better to use a smaller size, and that's the reason why in many cases we want to prepare powder. We first grind the powder or sieve the powder to obtain the fine particle or the small particle. طيب, another reason why particle size is important اللي هي penetrability of particles intended to be inhaled. Of course, you know that there are some preparations that are used for asthma, للربو, and now for even other indications, including diabetes. حتى diabetes, the patients who need to take insulin injections. Now there is a new product in USA market, and this product is for administering insulin by inhalation. طيب, anyway, the particles that are to be inhaled, they need to be of specific size in order to reach the alveolar region of the lungs. حتى توصل deep, in order for the drug to reach deep in the lungs, they need to be very small. Now, very small, طبعا, there are many studies. Some studies, they say it has to be from 1 to 5 micrometer particles. 1 to 5 micrometer. Some other studies say 1 to 3 micrometer. Anyway, for the optimum size of the powder particles to reach the alveolar region of the lungs, اللي هي, according to your textbook, it's 1 to 5 micrometer. What happens if the size is, let's say, 20 micrometer or above? In this case, most of the particles will impinge or will impact على, when you inhale it, يعني through the mouth, it will impact في الثroat, causing coughing and irritation. إذن, this means that it's very important for the particle size to be within the optimum range. طبعا, my PhD, when I did my PhD in UK, it was my task or my objective from doing the research there, اللي هي to reduce the particle size to optimum size, number one. Number two, to increase the amount of particle that can reach the alveolar region of the lung. طيب, فإذا size is also important in this case. Another reason why we need to control the size, for example, let's say when you are using the dusting powder, اللي هو البودرة اللي بتنحط على الجسم, the powder, the dusting powder that you apply to your skin. Now it has to be very small, otherwise you will feel grittiness. Grittiness يعني بتحسوا بالحبيبات. You will feel the particles and it will not be comfortable and it will not spread as you like. So in order to avoid grittiness of the dusting powders that you apply to the skin, you need to have very fine powder. طبعا, this applies to ointments and creams. Many ointments and creams, they contain solid powder. برضو this solid powder need to be very smooth, otherwise when you spread the ointment or cream on your skin, you will feel the particles, and that is what we call grittiness. في ophthalmic preparations, we have some suspensions that can be applied to the eyes. Ophthalmic يعني eye. Now, this preparation, if they contain particles that have size more than 10 micrometer, you will start to feel the irritation from these particles in your eye. But if it is less than 10 micrometer, then you will not have a problem. فإذا, the size is also important in this case. طبعا, what we explained so far, اللي هي only some of the reasons why we need to control the size of the powder particles. يعني, I did not say everything, I said some of the things. Okay? Okay, now, what are the methods? شو هي المethod that we can use to measure the particle size? Because as I told you, particle size is very important. It influences many factors. Now, one method that we can use, اللي هو sieving. With sieving, I already described to you the sieving process, and I have shown you a video about that. Now, in pharmaceutical preparation, usually we use sieves to measure particle size ranging from 40 micrometer to 9,500 micrometer. That does not mean you don't have sieves that are less than 40 micrometer. Actually, some sieve, في عندنا sieves اللي هي 5 micrometer. Which doesn't mean that you don't have sieves that are larger than 9500 يعني تقريبا 1 cm. This is almost 1 cm. We have sieves that have 1 inch opening. But in pharmaceutical preparation, mostly we will be using sieves ranging from 40 micrometer to 9500 micrometer. طيب. Now you have to be careful when your powder is mainly having a size that is less than 70 micrometer, because if the size of the particles, most of it, is less than 70 micrometer, this means what? This means that most probably the particles will be available as aggregates. يعني it will be difficult to separate the particles and sieve them unless you apply a really good force to sieve them. Because when the particles are smaller, as I said previously, the surface area increases, وبالتالي ال cohesiveness بين ال particles will increase. بصيروا ال particles they want to aggregate and agglomerate. That's why usually when we use sieving, we use it for powders that has majority of particles more than 70 micrometer. طيب طبعا this is showing you example of stack of sieves. طبعا at the top you will have the sieve with larger opening size, and at the bottom you will have the collector. طبعا another way to measure the particle size, but of course we cannot use it to classify powder to very coarse, moderately coarse, fine, very fine, اللي هي using microscope. Usually microscope is useful when we want to measure powder in the range from 0.2 micrometer up to 100 micrometer. It doesn't mean that you cannot see larger than 100. Okay? Now طبعا less than 0.2 it will be difficult to size them. With normal optical microscope it will be difficult to size particles with a size less than 0.2 micrometer. But more than 100 you can still size them, but we don't usually use the microscope for this purpose. Another method to measure the particle size اللي هي عن طريق sedimentation rate. If you remember, we talked about the suspendability of the particles, and we said that according to Stokes law, the larger the diameter, the faster is the sedimentation rate. Or actually, the rate of sedimentation according to Stokes law, rate of sedimentation اللي هو let's say rate يعني سرعة السedimentation يعني المسافة اللي بتقطعها الهايت by time. Okay, this is the rate of sedimentation, is proportional to the square of the diameter of the particle. طيب, we can use this equation, okay, to calculate the diameter of the particle. So we are measuring how fast the particles sediment, ماشي, in order to calculate the particles diameter. طبعا the optimum range that we can measure using اللي هو Stokes law, في عندنا جهاز اسمه Anderson pipette. Anderson pipette allows you to measure particle size based on sedimentation rate. Anyway, the range we can measure using sedimentation rate اللي هو from 0.8 to 300 micrometer. طيب, I like to add some information for you here. First, why we cannot measure less than 8? Why we cannot measure more than 300 micrometer? ما بدي احكي we cannot. We can, of course, but under certain precautions and under certain conditions. Now, if it is less than 0.8 micrometer, معناته the particles are very small. So when they are suspended in a liquid, Stokes equation, هذا Stokes law or Stokes equation, assume that the sedimentation is free. يعني the particles will go down freely. There is no obstacles for the particles to sediment. غير طبعا ال viscosity وال gravity. There is no obstacle for the particles to sediment to the bottom عشان يجي هون. Okay? In order to sediment to the bottom of the container. ما في عندنا ايش؟ obstacles. طيب. Now, if the particles are very small, بصير عندنا sedimentation is not free. The reason is because the particles are very small and the liquid in which the particles are suspended, this liquid has molecules. يعني أي liquid مكون من molecules من هذا liquid, from this liquid. So the molecules of the liquid surrounding the particles are, لأنه liquid هو, فبالتالي that's why, because it's a liquid, it's always moving. هاي المولكيولز always moving. Now, because it's always moving, and this phenomenon is known as Brownian motion. Brownian motion. إنه مش زي السوليد. لا, liquid, the molecules of liquid is always moving in different direction. Because the particles are very small, بصير هاي المولكيولز that are always moving is bombarding, is hitting the small particles that are trying to settle down. طبعا المولكيولز تاعت liquid is much smaller than the particle. But because the particles are very small, now the molecules of the liquid will start to affect the small particles in the liquid and not allowing these particles to sediment freely. Okay? That's why we use a centrifugal technique in order to overcome this problem. طيب, what about why not over 300 micrometer? Now, if the particles are large and they want to sediment, they will create turbulence. هم نازلين while they are sedimenting, they create turbulence around them. يعني هم نازلين كيف مثلا, for example, you are standing on the road and there is a big truck, speedy truck coming in front of you, very fast. It's passing in front of you, and you will find that there is a turbulence after this truck passes you, a turbulence of air. طيب, هذا turbulence that is created because of the movement of particles while it's sedimenting will disturb other particles in the suspension. راح يأثر على البارتكلز التانيات, and this will not allow for free sedimentation. طيب, طبعا as you see in this diagram that I have drew for you, طبعا there should not be so many particles in the liquid. If there is so many particles, what will happen? If a big particle is sedimenting, okay, and there is another particle beneath that one, or even if small particle is sedimenting and there is another particle under it. Why it is under it? Because there is so much particles in the liquid, then it will hit the other particle. معناته we don't have free sedimentation. Okay, so now I talk to you about sedimentation and how the measurement is done. It's based on Stokes law. Now we will talk about light scattering or laser diffraction. طبعا light scattering is a modern technique, or laser diffraction or scattering is a modern technique that allows you to measure particle size in the range, if it is light scattering, in the range between 0.2 to 500 micrometer, and if it is laser, then it allows you to measure size from 0.02 to 2000 micrometer, or even little more. طبعا laser طبعا is used for many things, including in surgery, especially you may يعني what comes to your mind, maybe the eye surgery that allows the correction of eyesight. When I went to UK, I used the machine for laser scattering. I used it a lot in order to measure the particle size that I have. So a friend of mine was warning me about laser. He was telling me that laser is an abbreviation, and this abbreviation means that looking at source erase retina. يعني if these beams, البيم الموجود هون أو هون because it will be scattering from here, يحصل له scattering. If these beams come to your eye, it can wipe your sight. يعني you will not be able to see. طبعا this made me scared. It's true it can do that, but actually it was different abbreviation, and it was just to warn me about the laser. So laser stands for light amplification of stimulated emission of radiation. يعني بالعربي باختصار it's an amplified light, يعني light مقوى، يعني ضوء مقوى. You can produce it by helium neon elements. Anyway, when laser beam go through a sample containing particles of different size, بصير عندنا scattering زي ما انتم شايفين scattering of the laser beam according to size. Now this scattering is collected when the photodetector. فالangle مثلا this is large angle, this is smaller, this is smaller, this is smaller, and maybe something will pass through the middle, no scattering. Now the angle will be related to the size of the particles in the sample. In this way, طبعا this will be connected to a computer to measure how much of the light is scattered in this angle and how much of the light is scattered in this angle, and depending on that they will know the size distribution. The size distribution. Okay. Anyway, so this is another way of measuring the particle size. This is more modern, and now we have actually we have one very nice equipment in our lab that allows you to measure the particle size based on laser scattering according to this principle. Now the other way to measure the particle size is through the use of cascade impaction, as you see here, cascade impaction. Now this is particularly useful for aerosols. And specifically I'm talking about powder inhalers or about pressurized meter inhaler. زي ما انتم شايفين هنا في عندنا inhaler or nebulizer حتى, and this is the something that resembles or similar to the lungs. Here you can consider this as the mouth, on the throat, and these are the throat, and here you have different stages. Now these stages represent the depth at which the powder will get inside the lungs. طبعا if the powder can reach the last stage here, معناته it's able to reach deep in the lungs, يعني to reach the alveolar region. طبعا the principle of cascade impaction is that if طبعا this one will be connected لوين, you see there is opening here, it will be connected to a vacuum, and when you press on this device to emit the dose, and this is connected to a vacuum, so air is flowing in this way, يعني from here, from the mouth to the vacuum. The particles in the airstream will pass through different stage, and in these different stage the particles will impact, okay, على plate if it is of suitable size. يعني larger particles will impact على the upper stage, the smaller one will go to the next stage, and so on. So that they will impact on the plate. Those which do not impact on the plate, they will travel to the next plate, okay, and so on. So the smallest particles will go on with the airstream until they reach the last plate. This is how it is done. Now, of course, you might ask me, okay, what is the size it will measure? Well, inside here, usually it's up to 20 micrometer, but from the throat and above, يعني من هون وفوق, it can be more than 20 micrometer, the particle size. So usually it will be useful when I want to measure particle sizes up to 20 micrometer. Okay, now we will talk about micromeritics. Now remember, in my explanation of the learning outcome, I told you micromeritics is defined as the science of small particles. So anything you study regarding the small particles, such as what is the size, particle size, size distribution. What do you mean by size distribution? We mean the particles of any powder are usually not of the same size. So some of them will be little large, some of them are little small, some of them in the middle, some of them are very, very small, some of them are very, very large. So there is a distribution of particles. So you want to study that. So that's micromeritics. The shape of the particle, it can be like fiber, it can be spherical, etc. The angle of repose, طبعا angle of repose is used to used for what? Used to describe the flow of the powder or granules. Okay, so it's used to describe the flow of the powder. Is it poor? Is it excellent? Porosity يعني the spaces between powders. True volume اللي هو the volume of particles without any inter or intra spaces, يعني بدون السبيسز between the particles. البulk volume اللي هو عبارة عن true volume and the spaces. Apparent density, bulkiness. طيب all these properties are studied under micromeritics and they are related related strongly to powders. So whenever we study powders, we need to study micromeritics. To start with, we will talk about particle size and size distribution. Imagine that you have used the microscope, استخدمت الميكروسكوب, you have a microscope, and in this microscope you want to look at the particle size. If you remember, we said microscope can be used to measure particle size from 0.2 micrometer to 100 micrometer. So imagine that you have a microscope. You want to look at the particle size that you have on this slide. طبعا, you know that when you want to look into something using the light microscope, what do? You take the slide, you put the sample, and then you look through the microscope. Now, in order to measure the size, then you will have what we call graticule. يعني the eyepiece, you need to insert in the eyepiece graticule. Graticule is a piece that allows you to look at the particle, okay, with a scale. يعني when you look at the particle through the eyepiece, you will see like a scale في eyepiece, okay, and this scale will allow you to look at the particle size. What is their size? طيب, so you need at least to measure 200 particles. in order to look at the size distribution and to be able to calculate ايش mean particle size. So you need to look through the graticule. We call it graticule. Okay. طيب, in our example here, you are going to look at 355 particles. As I told you, minimum usually 200 particles, and it can be up to 400 particles. You don't want to look at more because it will be really tedious, difficult for you to look at 400 particles and record their size. So normally 200 to 400 particles. Now, an important thing in the process when you look through the microscope into particles and start measuring, important thing is to classify particles to different size range. شوفوا هون, here we have size range, okay, 440 to 60, 60 to 80, 80 to 100, 100 to 120, 120 to 140. It's difficult that I take each particle and then record the size. In this case, if you do that and you take 200 sizes, شو بصير you need to add the 200 sizes together and then divide them by 200. It will be a kind of difficult way to do the calculation. The easier thing is to have what? To have the number of particles اللي موجود في الجروب 40 to 60. Number of particles in the group 60 to 80. Number of particles in the group 80 to 100, and so on. So how you do that? Okay, in the microscope, you are using the microscope. Okay, let's say you are starting from left, top left. You start moving to top right. From top right of the slide, you start moving to to bottom right. From bottom right to bottom left, and then you stop while using the microscope. In this case, you'll be able to measure at least 200 particles. So when you go to first particle, and this first particle is in the range between 60 to 80, معناته وين? It goes to this group, right? So the first particle is here. Then you start moving the slide in order to go to the top right, from top left to top right of the slide. So move to the second particle, and let's say it's 110. So it's in which group? It's here, in this group. So you'll put one here. Second one, let's say it's also 115, so also it's here. So I have now two in this group. The third one is, let's say 130, so it's here. Fourth one is here. Sixth one is here. Seventh, and so on. You'll start counting the particles, okay? For example, now I have 5 particles here. So you will continue doing this until at least ايش حكينا 200 particles are sized. In our example, we have 355 particles. So what do you have now? You have the size group, okay? You have the size group 40 to 60, 60 to 80, 80 to 100, 100 to 120, 120 to 140, and you have the number of particles in each size group. يعني من 40 to 60 I have 15, 60 to 80 25, 80 to 100 95, 100 to 120 I have 140 particles, 120 to 140 I have 80 particles, okay? Now when I look at this distribution in this table, when I look at this distribution, actually you will find that most of the particles are here. اللي هي 95 140. Most of the particles are here. فبالتالي I will expect that the average particle size will be from 80 to 120. ليش؟ لأنه most of the particles are here, so the average most probably will be in this range, 80 to 120. طيب, when you do this experiment, and you want to measure the average particle size, or what we call the mean particle size. يعني this is the size distribution. I can put it in a table, I can present it as a bar graph. يعني بقدر اجيب bar graph واصير احكي okay, this is the size. okay, هنا بيكون عندي السايز وهنا بيكون عندي الفريكونسي. I can do that to present the data, but I can also measure the mean size. How can I measure the mean size of these particles? Now I will have difficulty because if I have each size of the particle, يعني I have here 355 particles. If I have each size of the particles, I can add them together and divide them by 355 and I will get the average. It's like, imagine in your classroom, you have a quiz, and this quiz is out of, let's say, 10, okay? And one of you get 1, one of you get 10 out of 10, some of you get 5 out of 10, some of you get 9 out of 10, some of you get 7, etc. So how can I get your average? If I can get the mark of each one of you and then divide it by your number, I can get the average or the mean mean mark, mean score. طيب, now I don't have the size of each particle, because when I say here there are 15 particles, but their size range from شوفوا, it range from 40 to 60. So what do I do? طيب, in this case what you do is you consider that the size of 15 particles are average of 40 to 60. شو الافرج تاع 40 to 60? 50. So I will consider that the 15 particles here, each one of them has an average of 50 micrometer. Okay? طيب, someone might tell me, yes, but they don't have each one is 50. Yes, of course, you are right. Maybe particles are 40, some of them are 41, some of them are 50, some of them are 52, etc., etc. But I will consider that if I want to look at their average size, then their average size would be 50. In this case, I can consider that each particle has a size of 50. طيب, similar case here, 60 to 80, so the average is 70, 80 to 100, so the average is 90, 100 to 120, so the average is 110, 120 to 140, so the average is 130. So now you know the size of each particle. So what do? You want to add the size of each particles together. يعني هدول ال 15, each one of the 15 has a size of 50. So what is their total size? So multiply this into 50, and this is their total size. Again, I have 25 particles with average size of 70. What is their total size? Multiply 25 into 70 and you will get their total size. Okay, 95 particles have an average size of 90. Right? So what is their total size? So multiply 95 with 90. You get 8,550. Okay, I have 140 particles and their size is, average size is 110. So what is their total size? Multiply this one by this one. And here it's the same thing, 80 في 130. And this is the total. Now get the total of all, the total size of all these particles. شو مجموع السايز تاع كل البارتكلز اللي هم 355 particles? What's their total size? Total size is 36,850. طيب, this is the total size. Divide them by the number of particles. شو بطلع عنا? what do I get? I will get the mean particle size. هنا شوفوا, this is the equation. The average particle size is equal to sum of number of particles بالaverage size of the particles. يعني كنا شو نسوي? We multiply the number of particles بالdiameter, بالaverage size. And then we summed all these together and divided by the number of particles. What is the total number of particles? The total number of particles is 355. So divide 36,855 by 355 and you will get ايش average 103.8 micrometer. Okay, I want you to remember when I said, okay, most of the particles are here. So I expect that the average size will be from 80 to 120. And that's true. So شو طلع عندنا average size? What is our mean size? It's 103.8 micrometer as we expect. Please make sure that you write the unit. Why did I use micrometer? The reason is my measurement was in micrometer and my numbers were in micrometer. That's why I'm using micrometer. Okay, now we will talk about angle of repose. Angle of repose. طبعا, if you remember, I said angle of repose is to measure ايش? Or to describe what? It's to describe the flow, how the powder flow. Is it good flowing or poor flowing? Angle طبعا معناها زاوية, it's angle, okay? Repose, it means how it sits still, يعني الهجوع, السكون. يعني I want you to imagine you are at home and you have your flour, اللي هو طحين, you have your flour powder and you want to pour it on a flat surface. So when you pour the powder, what will happen? So you have flour and you are pouring it, and this is what you will get. You will get a heap or a pile. Okay? يعني راح يتكون عنا heap اللي هي كومة. What we will have is a heap. Now the way it sits on a flat surface سوت معنا angle. This is the angle. Now this is what I'm talking about. Now some powder will create large angle like this. Okay? With the same quantity, some other powder will create something like this. Some other powder will even create something like this. Okay. طيب, what is the difference between these three configurations? طبعا هون the angle is very high, right? Here it's little smaller. Here it's even more smaller, right? طيب, they say that this is related to the flow of the powder. So the way the powder sits in a flat surface is related to the powder flow. كيف? It says when you pour the powder on a flat surface, what affects this angle and this configuration or this repose, what affects this angle is mainly two things. شو هم two things? One, the gravity. The gravity wants the particle here at the top. Okay, if you have a particle here, the gravity is pulling it down. Okay? طبعا, if the gravity is able to pull the particles down, then this will reduce the angle. بصير عندنا الانجل صغير زي هيك. Okay, like in this figure. What prevents the particle from going down is, طب شو اللي ممكن يمنع البارتيكل? What can prevent the particle from sliding down? Okay, اللي هو الفريكشن with the other particle في الهيب الفريكشن والcohesiveness والinterlocking with the other particles. يعني الفريكشن the things that oppose the action of gravity اللي هي الفريكشن اللي هي resistance to flow. معناته if the particle has a lot of resistance to flow, it will stay at the top and the angle will be high. But if there is no resistance to flow and it can flow easily from the top to bottom, then you have small angle and you will have better flow. It's because you have better flow, you have small angle. So let's first say the following. The smaller the angle, the better ولا worse is the flow. طبعا the better is the flow. And the higher the angle, like in this case, the poorer is the flow. So by looking at the angle, we can indirectly, شو يعني indirectly؟ يعني بطريقة غير مباشرة, we can describe the flow of the powder. طب what is the direct way of describing the flow of the powder? الفلو شو هو؟ What is the unit of flow? The flow, if you have a powder, you should say how many grams are flowing in 1 second or 1 minute. But when you're looking at the angle, it becomes indirect way of describing the flow. So what you can do, or what we can do in a real experiment, and you may do this in your pharmaceutical technology course in 3rd year, you will take a powder and you will allow it to fall, and then you will measure the angle اللي هو هذا الانجل, you will measure it, and from this angle you will know how is the powder flowing. راح تعرفوا كيف الباودر is flowing. طيب, how can you do that in experiment? Okay, look at this photo here. طبعا you are not going to get this tool to measure the angle. We don't do this. We actually do the following. We consider that this heap has a height. height. This is your height. And here, from this point, يعني from the edge of the heap, okay, to here you have radius. شو يعني radius؟ يعني نصف القطر. The whole length to the other edge of the heap will be diameter. Okay, so what you can think of your heap is the following. Okay, and I will draw for you something here. Okay, so consider the following. Okay, this is your heap that has formed. Now, this is the height. Sorry. Now, this is the height. And this is, from here to here, is your diameter. Now, you have here a perpendicular angle, يعني زاوية قائمة, and you want this angle here. بدكم الانجل هون. If you remember math, the equations that you took in the math, if you have a triangle like this, هذا صار عندنا مثلث, صح? Triangle, and with perpendicular angle, and you have the height, الهايت اللي هو ايش؟ This one, and you have the radius. طبعا كيف تحسبوا الهايت? How do you calculate the height here? You get a ruler, a scale, and then you measure the height. Then you measure the diameter of the heap from this side to this side, and then you can get the radius اللي هو هذا صار الراديوس. هلا شو الراديوس عندنا؟ هون. يعني بالاكسبيرمنت you will measure the diameter وبعدين you will measure the radius to get this part. فصار عندنا ايش؟ Now we have this triangle, and I want to see this angle. I have the radius and I have the height. Now there is an equation, we took it back in the school, saying that in such triangle that have a perpendicular angle, tan the angle, this is the one which you are looking, is equal to the opposite. شو الopposite تاعها اللي هي height divided by the adjacent اللي هو المجاور. طب شو adjacent اللي هو نصف القطر. So from this equation you can, or you'll be able to calculate ايش the angle. طبعا when you divide height by radius you get a number. في الكالكوليتر use arctan and then you will be able to get the angle. Example: a powder was poured through a funnel and formed a cone. يعني سوى كون زي هذا الارتفاع تاعه, the height is 3.3 centimeter, و diameter يعني this diameter اللي هو 9 centimeter. What is the angle of repose? طبعا height is 3.3, diameter. Now I want to get radius, so I have to divide 9 centimeters by 2 عشان احصل على الراديوس R. فبصير عندي 3.3 divided by 4.5, and this will give me tan theta. It will give me 0.73. طيب how do I get the angle? Go to to arctan and you will get the angle. إذن calculator, we said 3.3 divided by 4.5, and then arctan, and you will get the angle which is 36.25. طيب إذن the angle is 36.25. طيب now is this يعني a small angle or a high angle? Well, refer to United States Pharmacopoeia, which says if the angle is from 25 to 30, it's excellent. It's good if it's from 31 to 35. It's fair and aid is not needed if it is 36 to 40. It's passable but may hang up if it is 41 to 45. Must be agitated and it's poor if it is 46 to 55, very poor 56 to 65, and very very poor if it is more than 66. Now what I want you to know is, I don't want you to memorize all these numbers, but remember for the particle size, for classifying the powder to very coarse, moderately coarse, or fine, or very fine, you need to memorize each category. يعني لما نحكي very coarse, you need to know that the highest, for example, size is 2.36, and and not more than 20% pass through sieve number 60. So you need to know these things, okay, اللي هو what is the upper size and what are the other characteristics. طيب now if the particle size is large, okay, when I say large يعني from 250 to 2000 micrometer, and this actually, if you remember our classification of powders, then this can be described as very coarse powder. Then usually it flows freely. يعني the particle when it's large it can flow freely. مين بيعرف ليش؟ وhow it can pass or can flow freely? Now do you remember the heap that we drew? هذا الهيب. if the particle is large here, even if there is friction between particle, because it's large, it will be able to overcome the frictions of this particle with the other particles. That's why it's able to flow even if there is some friction and cohesion. فإذا the larger the particle, the better is the flow of powders. If it is 75 to 250, it may flow or it may cause some problem. But if all the particles or majority of particles are less than 100 micrometer, then you may have a flow problem. Isn't there is a relationship between particle size and powder flow. Now what I need you to memorize, I need you to memorize that if the angle of repose is close to 25 or even 20, then you have a good flowing powder. If it is close or more than 50 degrees, then you have poor flowing powder. That's what I want you to memorize. Another important thing, now why do we need to measure flow of powder? Again, it has or it can influence many things. Maybe we'll discuss this later on in other topics. Now, other property that belongs to micromeritics, or we need to study it under micromeritics, is porosity, void, and bulk volume. شو يعني porosity, void, bulk, volume? Now imagine that you have this cylinder. It's a 100 ml cylinder and has particles packed inside. Now these particles are inside, okay, and let's say this is 100 ml cylinder. Okay. طيب. Now imagine that you have 50 gram of powder inside. So a measuring cylinder. This is the measuring cylinder. Okay, graduated measuring cylinder having powder inside. Now what you see here, you see the particles and you see the volume of the particle, and let's say here it's 80. يعني the 50 gram occupied a volume of 80. So this 80 ml of the 50 gram particles consist of the particle themselves, صح? Plus the spaces between the particles. يعني this volume is the volume of the particles and the spaces between them. Now this volume اللي هو 80 ml, we call it ايش? We call it bulk volume. We call it bulk volume. Now the volume of the particle without any space, طبعا this is cannot be achieved انه نخلي البارتيكل without any space even if we compress them. The volume of particles without any space at all is referred to as V. So when you calculate the V bulk اللي هو total volume minus the volume of the particles, طبعا the volume of the particles will be less than the total volume لأنه total volume عبارة عن إيش؟ Total volume is the volume of the particles plus the volume of the spaces. So when you subtract the volume of the particles from the total volume and divide it by the bulk, يصير عندكم ratio. مثلا for example, let's say 20 or 0.2. 0.2 الجواب لما يكون 0.2 meaning لأنه it will be of course less than 1. لأنه 1 يعني 100% spaces. لا مزبوطش. It will be less than 1. So 0.2 means there are 20% spaces in the 80 ml volume. This is what it means. Okay? So voids can be calculated as what? As the total volume اللي هو البulk volume. البulk يعني the whole powder volume اللي هو the particles volume plus the spaces minus the volume of the particles divided by the total volume of the bulk. Okay, so when you have too much voids, this has an implication بالpharmaceutical process. But one implication may be packaging. When you want to package powder, and the way the powder sets, it sets with a lot of spaces between them, معناته you need larger package. Okay? And the opposite is true. طبعا, yes, it needs larger package, but we consider the powder as light. Okay? صحيح انه why we consider the powder as light? Because there is a lot of spaces between the particles. طيب, now this voids, when I say the voids are 0.2, of course it can be without meaning for some people if I say it 0.2. But when I say it as percentage, by multiplying it by 100, فبتصير 20% voids, 20% voids, we call this term, اللي هو when I multiply it by 100, the voids multiplied by 100, we call it as porosity. يعني people will understand it as a percentage, as a porosity, more than as a fraction. يعني بدل ما نحكي 0.2, we use it as a percentage and we call it porosity. إذن porosity is the common name used to indicate how much spaces are there in the powder. Okay? Now, what about the apparent density or bulk density? Remember in this example I told you I have 50 gram and it's occupying 80 ml. 50 gram occupying 80 ml. If I divide the weight of the powder divided by the bulk volume, يعني الvolume which contains the particle and the spaces, okay, bulk volume, then I will get ايش? I will get the apparent density or the bulk density. يعني in this case 50 divided by 80 وراح يطلع عندنا الجواب. We will get the answer, and the answer will be in which unit? ml divided by gram, because gram, let me correct this, بيكون عندنا gram because it's weight, gram divided by ml, because it's 50 gram divided by 80 ml. The true density, طب شو راح يكون ال true density? Who knows? It will be the weight, okay, divided by the volume of the particle without spaces. This will be the true density. Now the true density is constant for each material. يعني كل material has its own true density. طب هل البulk أو apparent density is constant? No, it's not constant. Why? Look at this example. This is the powder inside the measuring cylinder. If I start tapping the measuring cylinder, يعني knocking at the measuring cylinder, the 80 ml will reduce, راح يقل, because the particles are coming closer to each other. فمعناته the apparent density or the bulk density changes, but the true density does not change. Now, what is the opposite or reciprocal of the apparent density? اللي هو 1 divided by the apparent density. This is, we call it bulkiness. Bulkiness. Okay, B. We give it a letter B. طبعا the higher the density, the apparent density, the higher the apparent density, معناته ايش؟ معناته this is a heavy powder. Okay, because the particles are close to each other. So the higher the apparent density شو بصير في البالكينس؟ the lower is the bulkiness. اوكي ما بيكون bulky، بيكون lower. ليش؟ لانه الapparent density high. طبعا opposite is true. شوفوا هون this is the measuring cylinder and there is powder inside. طبعا this is we call it jolting volumeter, because when you put powder inside the measuring cylinder you can operate this machine to tap the measuring cylinder. يعني بصير عندنا it goes up and down in order to allow the particle get closer to each other. طبعا it will not reach a state where there are no spaces between the particles. This cannot happen. There will always be spaces between the particles, but these spaces can get lower when you tap the measuring cylinder. طيب, what I want you to know, powder with a low apparent density. تتذكروا الapparent density اللي هو الويت على البلك فوليوم. لما يكون low شو بكون البالكينس تاعته؟ طبعا هاي، لانه شفنا احنا it's reciprocal. شوفوا البالكينس is ايش؟ reciprocal to apparent density. If it is low apparent density it has high bulkiness. معناته في هناك spaces, a lot of spaces between the particle. It will occupy large volume and need large container, okay, to put the powder. And in this case the powder is considered as light. بينما إذا كان high apparent density فالبالكينس تاعه بيكون إيش؟ small. In this case we will consider the powder as heavy. Okay, we'll stop here and inshallah we'll continue later in next video lecture. Thank you for watching, and we'll talk and I'll give you a lecture later inshallah. I hope you enjoyed this. Goodbye.